So, good morning, guys. So, last class, we have discussed about the basics of Kubernetes and the architecture of the Kubernetes and the components of the Kubernetes. So, what was the drawbacks in the Kubernetes and what is the advantages of using the Kubernetes? Also, we have discussed this in the last class. So, today, let's move forward. Couple more concepts which are very important concept as well, especially in the Kubernetes area. So let us take one um, concept called namespaces. So namespace is again is a Kubernetes concept. Is a way to organize the and isolate the resources within a cluster. So it helps manage multiple environments like dev, test, and prod, or different teams working in the same cluster by logically separation of their workloads. So in the sense, when we have multiple teams, like a developer team, we have testing team, we have production team, we have, I mean to say, we cannot directly test the whatever they developed codes in the prod environment, right? That is not the best practice. Initially we have to create a one separate development space in the Kubernetes area where you need to implement certain tasks. Suppose if you wanted to test some applications and you are going to enhance some functionality in the application, you are going to initially you have to validate or develop in the development area where we are call it as a separate namespace, so that it is going to isolate your work between all your different um, spaces. Like one is by default you are going to get a default work namespace, and different namespaces are there for by default. You are going to by default Kubernetes itself it is going to create. But on top of it, if you want to segregate your work for any enhancement, you are going to create a separate namespace. So so that is the called it as namespaces. So if you look at the default is one of the name by default it is going to create, and it is the default namespace for your workspace as well. Without specifying any namespace, you are going to land on the default workspace. And second one is cube system, is another default namespace which got created during the installation, and cube public, cube node lease. So these are the four namespaces which got created by default. Okay, so let's uh, get into the hands-on part so that you will get an idea how this default namespace works. So kubectl get namespaces. If we give ns also, so I think it's fine. Yeah, ns is namespace, the shortcut. So if you look at this, default is the one's namespace, cube node leaser is one namespace, cube public active is namespace, cube system is one namespace. So which got created by default after installation. So I wanted to create my own customized namespace for me. So let's um, look into that. Already there in namespace, I believe. Okay, let me use kubectl create -f namespace. So this namespace, as I'm so these things you no need to remember all these things. By default you will get, if you go to Kubernetes website, you will get all this uh, in the standard website itself. So you don't You no need to remember. Just have a look at what is this doing, what is the name, what is the namespace, what is the specifications it means. So what container it is, nginx container I am trying to create for the namespace, my namespace. Okay, so like that. So this is the command kubelet create hyphen app namespace is the command line utility to create your separate namespace. Namespace is not found. Okay, first we have to create a namespace. Hmm, let me create one namespace. Namespace .yml. So this is the one syntax. Initially, first create a namespace. Okay, so one namespace got created. Let's check get namespace. See, my namespace got created just 9 seconds ago,
Yes.
and I wanted to create a one pod into my namespace. I don't want to land my any pods on the default namespace. So get namespace. Okay, if you look at this syntax, the namespace, my namespace I had given in the name, my namespace here. That is how I'm instructing the controller. I'm instructing the kubectl to create a pod name nginx of the image nginx on the namespace, my namespace, and pod name is my pod. So like that, I just define this YAML file like this. Let's go ahead and create k um, create hyphen f name namespace. Okay, so now namespace pod got created on my namespace. Let's check kubectl get pod. If you give like this, it won't display because it is giving default namespace details here. If you wanted your own namespace, press hyphen n, and what is the namespace I had given? My name is space. The one namespace we have created now, this one we have to give. So if you see, so as I said, no, my pod is the pod name which got created and it is running now under the namespace called my namespace. So that is how you are going to segregate all your any new application development area or development something you're going to do some sort of development work or testing work. You are going to segregate your work like this so that it won't impact the existing any prod or ongoing projects. Okay, how to delete the namespace again? use the same YAML file, just use delete. So your pod got deleted. So nothing is there now. Only namespace is available. For that also you just delete -f namespace ml. So your namespace also got deleted. It means your development work completely removed. Now you just check get namespace. So your namespace is not available. So that's what I wanted to explain. A namespace in Kubernetes is a way of organize and isolate resources. So whatever the work you are going to do is completely isolating, and within a cluster it helps to manage multiple environments like dev, test, and prod. Okay, is it clear, Sunil now? Okay, hi Prashant.
Yeah, right.
So I think you cleared about this namespace, right?
Mm.
Okay, let's move on to the next concept called services and its types. So services in the sense, so once you created your pod, how are you going to access those applications which got installed or created under the pods, or the containers loaded on the pod? There should be some mechanism where you need to access those applications outside the containers, or the users in their browser, they need to access those websites. How are you going to achieve it? With the help of the concept called services. So services is an abstraction that defines a logical set of pods and policies by which they can be accessed. Okay, since pods are ephemeral and their IP address changes dynamically, services provide a stable network endpoints. Okay, and if you look at the types of the services, the cluster IP is one of the default service type, and it going to it exposes the services internally within the cluster. When I say internally within the cluster, as soon as you create your pods, you know so it won't expose us the outside the clusters, only the communication is happening within the clusters. So that is what it mean to say. So the service type got created cluster IP, so you cannot access those applications outside your cluster. That's what it mean to say. And one more type is node port. So node port is the exposes the services on each node's IP at a static port accessible from the outside the cluster. So when you define your applications as a node port, then you are able to access the applications outside the cluster, or in the internet also you are able to access with the help of the DNS or with the help of the public IP address. So that's what it means. And load balancer is again a browser and external load balancer routes external traffic to the service. It means to say when whenever you are deploying the multiple applications, so there should be a, like when I say, if you are creating 10 pods, you supposed to be keep under the one load balancer, right? So the traffic needs to distribute across the all the pods. So that's what load balancer is going to handle these loads, and it is going to balance all your traffics. External, I mean the external name in the sense that is again name. You are going to map the DNS names instead of the public IPs. And headless services in this is again no stable IP is assigned. DNS resolves to individual pod IPs instead of a single service IP. That means so these are all the different types, but you should majorly focus on the cluster IP, node IP, and load balancer. So these three plays important role. But again, just additionally you have to know the what is the additional name and headless services also. Sorry, but headless services is useful whenever you are going to do some mm, upgrades or patches. You are going to develop without downtime. You are going to do some testing on the applications, right? So in that cases, this sort of service types is going to help you. So let's go to one example so that you will get an idea of how this is going to help. Um, Let me create a one file, my cluster service. Is a folder services. Okay, so I'm going to create a one service called my cluster IP service. Okay, let me execute this one. I find up my cluster IP. Okay, so it got created on service. So there is one cluster got created with the cluster IP. So like this, it gonna looks like. But I wanted to create a um, one application on top of it so that you will get to know how to access this one. So let's try to access anything you're able to access. So what is the port we had mapped here? 8080. So nothing is exposed because when you define network service as cluster IP, so the scope of this service is within the clusters. So it won't expose anything outside, right? So that's what I wanted to explain here. Okay, we'll go to the uh, next thing called cluster IP. Sorry, node port. Um, there is a node port service already there. So here I'm trying to create one Nginx service. Okay, let's try. -f node port service. See now it got created. KQTSVC Nginx service got created and it exposes some IP, some port number 30080. Okay, Okay, get pod. So none of the pod got created now. But let's see if something, at least you're able to browse something. What is the port? 30080. So we just create one service, and but we did not create any imports. Let's create a pod, no, any one pod. Here create -f deployment. Okay, get pod. Okay, I'll explain it. This is a different concept, but I'll explain you on how to access, because we have ab- added a node port here. Container port 80. And what is the service? Service not dedicated. So this one, I will, one more concept is there, deployment. So there, I'll try to explain one real time project as well. Eh, Okay. Now I wanted to explain one important topic called the deployments. So far, whatever we have discussed, we just created only parts, and we just created services, and we are able to access these, websites outside. And see, the website got created, right? And we are able to access with the help of Notepad. Okay, leave it. Now, what if somebody accidentally deleted the container, or somebody unexpectedly it got deleted or crashed the container? So your application, it won't be able to access the outside, or the public, they cannot access this if anyone container goes down like this. So that The purpose of the deployment is you are going to make sure to create a multiple container, and if any one application, any one pod got created, deleted, so that it is going to maintain the replications, the number of containers. When I say number of containers, I'm going to set replication set equal to 5 or 3. It is maintaining the minimum 3 containers, minimum 3 pods, in order to serve the user's requests. That's what I wanted to explain. So let's go through an answer part so that you will get an idea how this thing is happening. So currently, all the setup is there in my, I'm going to create a one application, Python application, and I'm going to host um, on the Kubernetes, and let me maintain replicas is equal to 3, so that it is going to maintain the all the 3 sets of replications. Okay, now, so here I'm going to explain the, one one kind of project this is. So this project is consist of, it involves Git and GitHub. Okay, and I'm going to push my code to the uh, remote repository from my laptop, and it is gonna store in the GitHub. From there, it is gonna load onto the where on the target machine, Ubuntu machine, and then it is gonna create a one um, Python applications on the Kubernetes with the setup 3 containers. Okay, so we'll try that one. So currently, from my desktop, I just already loaded onto the, or let me make some changes and I will push. Okay, hello Kubernetes, hello cross Kubernetes from DevOps Bootcamp. So this is the message I wanted to display. Git status. So 2 files got changed. Git add, git push, git commit, hyphen m, Python app in Kubernetes KTS. Okay, git push. So it got pushed to the remote repository. Just go here and refresh. All your things are up to date. Let's check with the latest config. Okay, so this is a message we have applied. Now just clone the same into your local to your machine, so that you are going to get the exact copy. Ls. So here is my repository. Just go inside. So these are the files. We got it. Now let's try to create a one development. Sorry, let's try to develop. Sorry, deploy this thing Flask application. So this is the command where I am trying to build and push to my repository. Copy training or trainings. Let me reconfirm. Okay, trainings. GOPITRAINNGs. Okay, Copy trainings. So here I wanted to explain one more concept here. I am trying to maintain this our Flask image in the Git hub. Git set Docker hub. Docker. Here I'm maintaining all the Flask, image in the my Docker hub here, in order to avoid the each and every time you need to push, right. Once the you are going to push the thing, this one image, you can just reuse it. You no need to push the things, right. Here I'm just maintaining Flask app. Okay, I'm just rebuild once again. So where it is considering whatever the files we created, no, these files it is going to consider. So Docker build is the command, to build the whatever the files you have provided here in the Docker file, and it is gonna package the things and going to push to your. It is first, making a image in the locally, so it got created. See, successfully tagged Gopi training flag as latest. Now I'm going to push the same thing to the Docker hub. For that you need to use Docker push, because I did some changes, right. See, this was pushed 1 hour ago. Now if I push now, it's supposed to push the latest one. So Docker push requires exactly one argument. Upload image to repository. Just mm, let's use go ph one more location. 1 2 3 4 5. I wanted to let me keep inside this one. Go p 1 2 3 4 5. What happened? Okay, it is uploaded. If you refresh here, so image got. What happened? It did not push the bill. Docker push requires exactly one argument. Docker push hyphen L. Okay, what is was trying to say? It is trying to tag OPH 3 4 5. Okay, let me rebuild it so that it is gonna tag in a different way. Oh, I missed the colon. It's okay. Okay, so it got tagged so with the some name. That's okay. Now docker push. What happened to this? It's okay. Huh? This is we are going to complicate the things. Anyway, we have already pushed the image. So let's move on to the deployment part so that you will get an idea how this one will gonna work. Um, kubectl apply -f deployment so that it is gonna create a uh, pods services. Let me cat this one so that we will explain. See, I'm going to create an app called Flask app, and container name is Flask hyphen container, and deployment name is Flask app. See, the deployment name is Flask app. Replications three, in the sense it is gonna maintain a three replicas of the server pods. Okay, so it is gonna again create a service called Flask service, and it is using the node port, the service name. So let me create first kubectl. I create -f deployment. Okay, so deployment created as well as service also created. Let's check kubectl pod get pods. Kubectl. So now how many pods it got created? It got created three pods. Have you seen? Three pods are running. Flask
Yes,
app,
3 pods.
three pods got created. Now I will show you one how the replication hot oiling is happening. I wanted to delete one pod. See, I'm going to delete this part. How this replication set is going to maintain the three sets. See, we are intentionally deleted one pod. Okay. In the background, the Kubernetes deployment is, immediately is going to create the another pod, which needs to maintain the replica set of three pods. Okay. So I'll let it complete. It should not take this much time. Oh, okay, done. kubectl get pod. Now, if you notice, it got created one more pod just 38 seconds ago. We have intentionally removed one pod. It is maintaining the consistency of three pods. That's what we mentioned in the deployment, right? I had shown you replica is equal to three, so that's what it means to say. So let's modify one more, no, two more. I wanted to give replica set is equal to 5. It means I want a minimum 5 pods to be up and running always. Let apply -f deployment so that, what is this, kubectl I apply -m deployment. Okay, no problem. kubectl get pod. How many we have now? 5 pods are running because that's how I had mentioned in the deployment replication set. If I'm deleting any one server also, any one pod, in the background it is going to take care of your replication, and it is maintaining the 5 replica sets. kubectl delete pod. Let me open this application so that I wanted to show you users should not feel that there is a something is happening in the background. So they don't user don't want to disturb the connections, right? That's what I wanted to show. Um, there is a service 3007. What is the port number I've given? Okay, 3007 007 3007. See, hello. So this is a message I wanted to display, and I'm pinging you guys. You just try to access same message you are getting or not. Access this URL. Anyone?
Okay.
You're able to get this message. So allow from Flask in Kubernetes.
1 second. Okay.
If not, not an issue.
Yeah, I'm getting.
You are getting a see now. I'm trying to delete on pod, and you also refresh so that you don't feel that something is going in the background. Pods are automatically auto healing is happening. User should not feel there is a delay in the access part, because Kubernetes is it is self-healing. It is gonna maintain the consistency of the replication set, and user should not feel that there is an issue in the application side.
Okay.
If you refresh also, still the load balancer is happening in the background, though it is deleting. So it means
Yes.
the replication set is maintaining in the background. It is deleted, though users they don't feel that they need buffer. The loading is they don't feel that there is something is happening. It's automatically created. And I wanted to I don't want to edit always this deployment part. uh, I mean to say, I wanted to spin up the multiple replication set in the command line itself. I don't want to edit always this deployment file. So there is one command. Um,
Prashant has to go to mute.
how to change the replication set in Kubernetes. How to change the replication in Kubernetes. So Okay, kubectl scale. Give me a second, let me grab that one. Okay. So kubectl replication set, get replication set. So this is my replication set. So how to scale this one? Kubectl scale hyphen replic is equal to, currently we have 5, I'm going to replicate to 10. Replica set is equal to, let's try this one or not. Okay, it got succeeded. Let's check the 10 parts got created or not. Kubectl get parts. Some issue with the replication name. Cat deployment. So what is the deployment? Flask app. Kubectl scale hyphen replicas is equal to 10. Replicas set is equal to flask app. It is showing error. Okay, no worries. So there is a, I think for that we need to create another replication set, but not an issue. Just to understand the existing one. Okay. You CTL get pod. So it is maintaining the 5 replication set, and your application also able to access without any issues. And if any something goes wrong in the background also, you are, it is automatically auto healing your another pod, and the it is able to serve the requests. Okay, so that is what I wanted to explain. This is again one kind of a project only. See, I am using the GitHub for storing all the configurations things, and uh, after that it is going to land on the EC2 machine, and it is going to create your Flask app. It is going to install the dependencies, Flask installing, this one also installing, And so these are all the Docker file contents. It is going to pull the Python image, and all these things are performing in the image. It is going to install the things, and it is going to expose the port number. Okay, and in the background, it is going to create a one deployment. The deployment name is Flask app, and it is maintaining a replica setup 3, and also it is trying to push the images or pull the images from the Docker up where our images are stored for our project purpose, and it is going to again create the services called Flask service, and your application is able to serve like this. So again, I want real-time kind of real-time applications. So except the message, the things are going to, the in the background, every the concept is same. Only you're going to do the different messages. You're going to apply the different, concepts here. Right now, this is one use case in the real-time applications. And I want to demonstrate one more, but we are most, where is the PPT? So that's what service types. There is one more concept called persistent volume and persistent volume claim. In the Docker, we are discussing volumes, Docker volumes, and it is gonna help you in terms of securing your applications in the safe side, right? That's what in the Kubernetes persistent volume comes into the picture. It is gonna maintain, or it is gonna gives you the piece of space for keeping all your configuration information in a safeguard manner. So that it is going to help you in the high available applications, and it is gonna whenever you are going to crash your applications, the same content is going to help, especially if you are developing any database related applications. Your data should not be loose across your pods, right? So that using this concept, it is gonna help you to maintain all your information in a safer manner. So probably next class we are going to discuss little more topics, so that you will get an idea on what is this PVC, PVM and all.
Okay.
So up to now, any questions? So this code is available here itself. If you go to your Git repo, if you try to access this one, you are
Yeah.
able to get all the code. After
Okay.
login to your GitLab, in the search bar, if you type this one, with this one, you are going to get the code. Whatever the code I have pushed here, no, all these files you are going to get it, so that you can clone it and you can try to practice. So this is open public, right? So you are able to get all this code. Okay, let me stop these instances. First, let me delete it. Kubectl delete hyphen f. If I give dash dot, it is gonna delete the entire thing. Kubectl. Okay, it is deleted deployment as well as services. So you no longer have able to access. Let me stop the instances.